Space, the vast, uncharted expanse that has captured humanity's imagination for millennia. From the first time humans looked up at the stars to today's ambitious plans to colonize Mars, the journey into space has been one of the most remarkable achievements in science and technology. But how do we actually leave Earth? What science makes space travel possible? Today, we'll explore the incredible physics, technology, and future innovations that allow us to venture into the final frontier. Begin with a brief historical perspective. The idea of space travel isn't new. Humans have always been fascinated by the stars. But it wasn't until the 20th century, with the development of rocketry and scientific breakthroughs, that we finally made our way off the planet. Mention the significance of historical missions such as the Apollo moon landings and how we've progressed from these early steps to planning missions to the moon and Mars. Introduce the main topics of the video. We'll cover the physics that enables space travel, the challenges astronauts face, the cutting-edge technologies making missions possible, and what the future holds for interstellar exploration. Section 1. The physics of space travel. At the heart of space travel is physics, specific laws that govern motion, gravity, and energy. Understanding these laws allows us to propel spacecraft out of Earth's atmosphere and into the cosmos. 1. Newton's laws of motion. Start with Newton's third law of motion. For every action, there is an equal and opposite reaction. This law is the foundation of rocket propulsion. When rockets ignite their engines, they expel gas at high speeds in one direction, which in turn pushes the rocket in the opposite direction. This is the basic principle behind rocket launches. Example: take NASA's famous Saturn V rocket used in the Apollo missions. When its engines fired, they expelled gases at 10,000 feet per second, propelling the rocket upwards with tremendous force. 2. Escape velocity. Explain that escape velocity is the speed needed to break free from Earth's gravitational pull. To leave Earth, a spacecraft must reach a speed of around 11.2 kilometers per second, or about 40,000 kilometers per hour. This requires an immense amount of energy, and is why rockets carry so much fuel. Discuss how the energy required to reach escape velocity depends on the mass of the planet or celestial body. For instance, the Moon has much lower gravity than Earth, so spacecraft leaving the Moon require less fuel. 3. Orbits and trajectories. Orbits. Once a spacecraft reaches space, the vast, uncharted expanse that has captured humanity's imagination for millennia. From the first time humans looked up at the stars to today's ambitious plans to colonize Mars, the journey into space has been one of the most remarkable achievements in science and technology. But how do we actually leave Earth? What science makes space travel possible? Today, we'll explore the incredible physics, technology, and future innovations that allow us to venture into the final frontier. Begin with a brief historical perspective. The idea of space travel isn't new. Humans have always been fascinated by the stars. But it wasn't until the 20th century, with the development of rocketry and scientific breakthroughs, that we finally made our way off the planet. The significance of historical missions, such as the Apollo moon landings, and how we've progressed from these early steps to planning missions to the moon and Mars. The main topics of the video. We'll cover the physics that enable space travel, the challenges astronauts face, the cutting-edge technologies making missions possible, and what the future holds for interstellar exploration. Section 1. The physics of space travel. At the heart of space travel is physics, specific laws that govern motion, gravity, and energy. Understanding these laws allows us to propel spacecraft out of Earth's atmosphere and into the cosmos. Orbits and trajectories. Orbits. Once a spacecraft reaches space, it needs to stay in orbit, which means it's moving forward fast enough to counteract the pull of gravity. Satellites and space stations like the International Space Station, ISS, remain in orbit because they're essentially falling toward Earth, but their forward momentum keeps them moving around the planet. Section 2. The challenges of space travel. While space offers a limitless frontier, it also presents some of the harshest and most unforgiving conditions known to science. 1. The vacuum of space. Space is a near-perfect vacuum, which means it lacks air, atmosphere, or pressure. On Earth, we rely on atmospheric pressure to breathe, but in space, there's none. To survive, astronauts require pressurized suits and spacecraft that mimic Earth's environment. How astronauts rely on life support systems. These systems control oxygen levels, remove carbon dioxide, and regulate pressure and temperature inside their suits or the spacecraft. 2. Microgravity. Microgravity. In space, astronauts experience microgravity, meaning they're essentially weightless. While this may seem fun, it has serious effects on the human body. Prolonged exposure to microgravity leads to muscle atrophy, bone density loss, and fluid redistribution. How astronauts counteract these effects. Astronauts aboard the ISS spend hours each day exercising to maintain their muscle mass and bone density, using specially designed treadmills and resistance machines. 3. Radiation. In space, astronauts are exposed to dangerous levels of cosmic radiation and solar radiation, especially during long missions beyond Earth's protective magnetic field. This radiation can damage DNA and increase the risk of cancer. 4. Temperature extremes. Without an atmosphere, space can get extremely cold in the shadows and intensely hot in direct sunlight. The temperature can swing from -270 degrees Celsius in the dark to over 120 degrees Celsius when exposed to the sun. Section 3. Current space travel technologies. The vehicles and technologies that take us to space are marvels of modern engineering. Let's break down how today's spacecraft work and what innovations are pushing the boundaries of space travel. 1. Rocket technology. Rockets remain the most reliable way to reach space, using chemical propellants to create the massive amounts of energy needed to break free from Earth's gravity. Solid rockets. These are simpler, with fuel and oxidizer mixed together in a solid form. Once ignited, they burn until all the fuel is used up. The Space Shuttle's solid rocket boosters are a prime example of this technology. Liquid rockets. Liquid rockets, like those used in SpaceX's Falcon 9, offer more control. They can be throttled or shut down as needed, making them more efficient for precise missions. Liquid oxygen and hydrogen are common fuels. 2. Reusable rockets. A groundbreaking innovation in space travel has been the development of reusable rockets. In the past, rockets were discarded after launch, but companies like SpaceX have revolutionized the industry by making rockets that can return to Earth and be reused. The Falcon 9, for example, has drastically reduced the cost of space travel by reusing the first stage of the rocket multiple times. This reusability is essential for making future missions, including those to Mars, more affordable. 3. Spacecraft and capsules. Once a rocket reaches space, the crew or cargo is housed in a spacecraft or capsule. Modern examples include SpaceX's Dragon capsule, which can carry astronauts to the ISS, and NASA's Orion spacecraft, designed for deep space exploration. 1. Colonization of the Moon and Mars. One of the most ambitious goals of space agencies like NASA and private companies like SpaceX is the colonization of other planets. NASA's Artemis program aims to return humans to the Moon by 2025, using it as a base for future Mars missions. Mars presents the next great challenge. SpaceX's Starship is designed to transport large numbers of people and cargo to Mars, with the goal of establishing a self-sustaining colony there. But living on Mars will require solving problems like radiation exposure, thin atmosphere, and the lack of liquid water on the surface. 2. Space tourism. In recent years, space tourism has become a reality, with companies like Blue Origin, SpaceX, and Virgin Galactic offering suborbital trips for paying customers. These trips give people the chance to experience weightlessness and see Earth from space. As technology improves, the cost of these journeys is expected to decrease, potentially opening space travel to a wider audience in the future. 3. Interstellar travel. While our current technology allows us to explore our solar system, interstellar travel remains a distant goal. The vast distances between stars mean that we would need radically new propulsion technologies to make the journey within a human lifetime.